Hey folks, welcome to this episode on oxyanion acid nomenclature. So we know oxyanions, they're just basically polyatomic ions that contain oxygen. So we have seen ones that don't contain oxygen such as NH3, but things like carbonate, nitrate, phosphate, sulfate, chlorate, these are all things that contain oxygen and they're called oxyanions. As we saw before when we talked about ionic naming, they also keep their full names when they're in compound. Now, we did talk about base oxyanions, polyatomic ions, and those are, again, nitrate, phosphate, chlorates, carbonates, and sulfate, but they can also exist with a different number of oxygen atoms, and they still have the same charge. That's the key. These things that do exist with more or less oxygen atoms, they still remain as the same charge. So, for example, we know that the base ion containing carbon is carbonate, and that's CO3 2 minus. So 2 minus, and it has C3 oxygens. But it can also theoretically exist as these different species here. Now, it's all starting with carbon, so it's all going to be carbon something, but what that is, we're going to see in a second. So when it comes to naming these oxyanions that have different amounts of oxygens from their base anion, we use a kind of prefix and suffix system to show that. Now, it's all based on how many oxygens they have compared to that basic or base ion. So, for example, in carbon, something that deals with carbon, it's CO something, and our base ion we call carbonate, CO3 2 minus. Now, remember, all the charges should be the same, but the oxygens might differ. So here, when we go between CO3 2 minus and CO 2 minus, what have we done? Well, we've actually lost, from here to here, we've lost 2 oxygen atoms. So our base would be right here. This is where our base sits. And we've lost not 1, but we've lost 2 oxygen atoms. So that turns it into carbonite. That would be if it lost 1. If it lost 2, well, now it's hypocarbonite. Now, hypo just means short of or missing. So if you're hypoxic, that means you don't have enough oxygen. If you're hypothermic, it means you don't have enough heat. Now, CO2 2 minus, well, our base ion is CO3 2 minus, and we're going to CO2 2 minus. So here we've only lost 1 oxygen atom. So here's our base again, and we've lost 1, so it's going to turn into ite. So all it is carbonite. Now, if we go from CO3 2 minus to CO4 2 minus, what we see is that we have gained an oxygen compared to our base ion. So if we're gaining, we're going in this direction, and it's already at 8, but we add a prefix per to show that it has an extra oxygen. So it's going to be per carbonate. So again, these prefix and suffixes show plus or minus oxygens compared to the base ion. So what that really means is that you really, really, really need to know and memorize those base ions. Now, this is a way that might help you. It's called Nick the Camel ate a clam for supper in Phoenix. Now, the beginnings of all of these names, for example, the N, the C, the Cl, these all relate to those base polyatomic ions that we've talked about. So, for example, Nick is nitrate, the camel, Ca, is referring to carbonate, Cl is chlorates, Su is sulfate, and P is phosphate. Now, the reason this is underlined as 8 is because all of these, as bases, exist in this 8 format. So the suffix will be 8. Now, in this case, when we look at this, the consonants in the word tell you how many oxygens. So, for example, for N, which stands for nitrate, there are 1, 2, 3 consonants. Those 3 consonants means it's going to be NO3. Okay, now what's the charge for NO3? Well, if we look to the vowels, the number of vowels, that's going to give us the charge. Now, there's only one vowel here, so it's going to be NO3 1 minus. So this could be a way that you remember. If this helps you, perfect. If not, and you just remember through straight memorization, that's fine as well. So again, here what we're looking at, just kind of a summary. If we have our base, which are usually the 8s over here, okay? If we subtract 1 less oxygen, we'll have ite. If we subtract 2 less oxygens, then we'll have hypoite. If we add an oxygen, that we're going to have per as your prefix. Now, remember that different compounds will start off with different oxygens. So, for example, nitrate will have 3 oxygens versus maybe phosphate, which has 4 oxygens. So, for example, this will be NO2. This might be NO. this would be NO5. Now, not all of these exist, but you'll get the idea. Now, again, phosphate starts with 4, so one less would be PO3, here would be PO2, and this would be PO5, theoretically. Okay, so it all depends on how many oxygens they start with, and then the change in oxygens that will dictate what suffix and prefix they have. So let's do some practice here. So the first thing we have PO5 3-. So this looks very similar to PO4 3-, which is phosphate. That's the base polyatomic ion that contains phosphorus. Now here we go from PO4 to PO5, again 3-. So we have gained an oxygen. And this means that we are going to, it's already going to be at 8, but we add the prefix per. So this is going to be per phosphate. Now, in ClO2-, this really looks very similar to our ClO3-, which is our chlorate. Now, to go from here into the one that we have on the slide, we have subtracted 1 oxygen. So, we now have to change the ending from 8, which is chlorate, is the ClO3-, into a new suffix. It will be chlorite. And the last one looks very similar to our sulfate polyatomic ion. So we go SO4 2-, and right now it's SO2 2-. So to get here, we've actually subtracted 2, or we've removed 2 oxygens from this. So we start off with, in this case, we have sulfate. If we put into SO3 2-, it would be sulfite. But again, we've removed 1 more oxygen. So in this case, it's going to be hyposulfite. Now, when you mix these into a compound, remember that they do keep their full names. So, just like any other ionic compound, we first have to figure out what this name is, the PO5. Now, we remember from last slide, this looks very similar to PO4. This is PO5. We've added an oxygen here, and this again is 3- and 3-, that hasn't changed. So, if this one right here is phosphate, then this is going to be called perphosphate. So when it comes to naming, we have aluminum perphosphate. Okay? Same thing here. We saw this one before, ClO2, and the charge is minus, and we recognize that as chlorite. So in this case, it's going to be calcium chlorite. And finally, we recognize the SO2 2- was called hyposulfite. So this is going to be, and remember, in order to figure out what this is a multivalent metal. So we have to figure out what the charge outside of this bracket is, and it's 1 goes there, the 2 goes over here, and we see that this is 1+, this is 2-. Is the charge of SO2 2-? Yes, it is. So that means that this is the charge of the metal. So that's going to be copper 1 hyposulfite. All right, so in this case, when we look at acids, we have 2 different types of acids. We're going to be looking at oxyacids and binary acids. Binary acids is when you have just a hydrogen atom attached to a single nonmetal. And an oxyacid is when you have a hydrogen attached to an oxyanion, so ones that we have been dealing with before. Now, in terms of a binary acid, it all depends on the state. If they're in an aqueous format, that means that they've been dissolved in water and they exist as an acid. So, if you have this aqueous state, you're going to be naming it as an acid. If it's a solid state or a gas state or something like that, then we just name it as it is as an ionic compound. So, for example, if we had HCl, solid, it would be just named hydrogen chloride. And we saw that before. We omit the monos when we deal with hydrogen and another nonmetal. But if we see HCl, well, this is now existent as an acid. And so what we do is we add hydro. Here's our chlorine, the chloric. And the ending turns into an ic acid. So it would be hydrochloric acid. So you have your hydro, your nonmetal, and your ic acid ending. So if they're aqueous, that means they exist in a dissolved form. And if they contain a hydrogen, that means it's going to be as an acid. So hydrochloric acid. So here, just pause the video, practice, and see if you can get these names. Pause it right now. We'll come back with the answers. All right, welcome back. So here we see our first one. We have to look at the states. HBr aqueous is hydrobromic acid, but then when we look at the second one, it's a solid. So that is no longer an acid, it's just a regular covalent compound, so it's hydrogen bromide. HF with the aqueous, hydrofluoric acid. Now, naming oxyacids is very similar to naming your oxyanions, except that, again, we have to change the ending depending on whether or not, depending on how many oxygens it has compared to that base oxyanion. So in similar, when we were looking at our previous table, if it was our base, it would have the ending 8. If it was 1 minus our base, it would be ite. And if it was 2 minus, we would have hypo-ite. If it was plus 1, it would be per 8. So what we see here is that this table is almost directly related to here. If it has if the oxyanion has an ending of ite, it turns into -ose when it's an acid. Same thing, ite turns into -ose. If it has an ending of 8, it turns into -ic. Okay? So again, you look at your base polyatomic ion. If it has one more oxygen, it still keeps the per, but the 8 ending turns into -ic. If you have, for example, two less oxygens, you still have that prefix hypo, but that ite ending for the oxyanion turns into -ose for the oxyacid. So again, here's just a little chart of showing what's actually happening. When we look at, for example, the bromate ion, which is BrO3 minus, the bromate, this 8 ending just turns into -ic acid. So bromate 8 turns into -ic acid, and all that we've done is that we've added 1 proton, and that comes through the charge. So when we look at bromine, bromate minus, and then we look at hydrogen, which has a plus. We do the same thing as before, cross, cross. So that 1 plus goes out here, that negative charge goes out here, and we get HBrO3. If we look at something like, for example, carbonates, CO3, this is a charge of 2 minus, we have hydrogen, which is a charge of 1 plus, cross, cross, and we get H2CO3. And again, this would be both in aqueous formats. So once again, the 8s turn into the -ic acid. Okay, same thing. This 8 would be the -ic acid, but except it still has that prefix. The ites, on the other hand, turn into -ose acid, and if they do have a hypo, that also remains consistent. So in this case, let's just do an example here. We have H2SO4. Now this was created by having a hydrogen with a plus 1 charge and SO4 with a 2 minus charge, and we cross, and we get H2SO4, and this is again aqueous. Now here this would be called sulfuric acid because you have the sulfate group, which is SO4 2 minus, and the 8 part turns into -ic acid. So all it is sulfuric acid. On the second example here, again, you have SO2, and this is again H plus, and we have SO2. It still has 2 minus. Remember that charge doesn't change. Cross, cross, and we get H2SO2. But when we look at the SO2, to figure out this name, let's compare it with the SO4 2 minus, its base ion, SO2 2 minus, and from here to here, it's lost 2 oxygen atoms. So this was the 8 when we were looking at oxyanions. If it lost 1, it would be ite, and if it lost 2, it would be hypo-ite. So this would be hyposulfite. Now remember that this ending ite, when we add some hydrogens to it, these hydrogens over here, that ite turns into -ose acid. So putting it together, we get hyposulfurous acid. Hyposulfurous acid. So here, let's look at these. The first thing we need to figure out is what is the name of the oxyanion. So in CO3, this looks exactly like our base ion that contains carbon, which is called carbonate. Okay? Carbonate. Now that 8, when it's bonded to some hydrogens, turns into ic acid. So this is going to be carbonic acid. ClO2, well, that looks very similar to ClO3 minus. Now, ClO2 minus, that means that we have lost one oxygen atom. We've gone from 3 oxygens to 2 oxygens. We've lost one oxygen atom, so that means that this the chlorate turns into chlorite. So now in this case, the ite, what does that turn into? Ose. So this is chlorous acid. And the last one here, H3PO5. So again, PO5 looks like PO4 3 minus. So PO5 3 minus. To get here, we have added an oxygen. So PO4 3 minus is phosphate. When we add an oxygen, that turns into perphosphate. And once again, that ending 8, when we add some hydrogens and make it into an acid, it turns into ic. So this is perphosphoric acid. So take a moment and try to practice. There are a combination of binary and oxyacids here. So try your best and we'll come back with the answers. So go ahead, pause the video now, try it, we'll come back. All right, welcome back. So here we have the first one, SO3. SO3 looks like the base ion of SO4 2 minus, except that it's missing one oxygen. So that missing one oxygen would be called sulfite. And remember that those ites turn into oses, so it's sulfurous acid. H2S, well that's not an oxyanion at all. It doesn't contain any oxygens. It's simply hydrogen bonded to a sulfur. So that is a binary acid. Now with binary acids, we put the prefix hydro, sulfuric acid. This SO4, again, SO5, excuse me, looks very much like the SO4, except it's adding another oxygen. It contains one more oxygen. So that would be persulfate. That 8 turns into ic, and we still keep that per, so it would be persulfuric. Hyposulfurous is this one. It's 2 less oxygen, so we keep that prefix hypo. That would be an ite, which turns into ose, and we have hyposulfurous acid. And here's our base ion, SO4, sulfuric acid. So again, just pause the video and see if you can come up with the formula for each acid. So figure out what the ion is, the oxyanion, and then add the number of hydrogens that you need based on the charges. So go ahead, pause the video, we'll come back. All right, welcome back. Here are your answers. So the first thing that we need is chlorous. Well, that is similar to chlorate, which is ClO3 minus, but it says hypochlorous, so that means that it's lost 2 oxygens. So that means that this would be ClO minus. Now we want to make it into an acid, so we have to add a hydrogen. So hydrogen has a charge of plus, hypochlorous has a charge of minus, cross cross, and we get HClO. Remember, aqueous, it's an acid. Persulfuric acid, again, so here's our sulfate ion, SO4 2 minus. Persulfuric means that there's one more oxygen, so SO5 2 minus. Again, we need to add hydrogens to make it into a acid, so cross cross. Then we get H2SO5. And this last one is the chromate ion, so that is CrO4, that's 2 minus. Again, we have hydrogens. Now it's chromic. That means that this is going, ec turns into 8. So it's just simply the chromate polyatomic ion. So it's just CrO4 2 minus. And again, we cross, we get H2CrO4. That's it for this one, guys. Thanks so much for watching. See you soon.